This is Shaken Not Stirred, How Shaking a Mixture Affects the Solubility Rate of Salt in Water by Matt and Jack.
General information: it is common knowledge that shaking a solution will affect the particles being dissolved by making them dissolve faster. This is especially true in a widely used mixture of salt water.
So how this relates to our experiment. We tested how different rates of shaking will affect the salt that is trying to be dissolved within it. Both of our mixtures were shaken for 1 minute, but at different rates.
The problem we are trying to answer, our group is trying to determine how shaking a mixture, which is 50 milliliters of water and 5 grams of table salt, affects the solubility of the mixture.
So we created a hypothesis, that is, we determined that the faster and more rapid we shake a mixture, the faster the salt crystals will dissolve in the mixture.
Materials and methods. In our lab, we did 2 separate tests. We filled a beaker with 50 milliliters of water and added 5 grams of table salt. Then we shook each mixture for 1 minute, but at different rates. The first test we shook rapidly, which is very fast, and the second test we shook very easily.
This picture here shows the scale in which we measured out how much salt we were using. We tried to get as close to 5 grams as possible. As you can see, we got 5.01, but that did not affect the test we did in any negative way.
As you see on the left, the picture 1.2, there are 3 materials we used for this experiment. 5 grams of salt, a rubber stopper to stop the liquid from escaping, and a beaker with 50 milliliters of water.
In this picture, we can see that we have added the 5 grams of table salt to the 50 milliliters of water, and this is before any shaking has taken place.
Materials and methods continued. Both shakers for our beakers are 16 or 17 male and are able to shake at the correct force to have this experiment go correctly. If we did not shake easily, the same result would have been given as when we shook rapidly.
These are just 2 pictures of us doing our experiments. On the left is me as I am shaking my test beaker rapidly, and on the right is Jack as he is shaking his easily. Okay, so our first test was where we shook rapidly. Here we see the product of the first test in the picture to the left, 1.6. It is a very cloudy color because of the dissolved salt. If you look very closely, you can see that there are also no salt crystals present, which means that the rapidly worked well.
Second test. Shake easily, not stirred. The second test we relatively the same as the first. We shook the same mixture or a minute as well with 50 milliliters of water and 5 grams of salt. However, in this mixture, by looking closely, you see that the presence of the salt crystals have not dissolved, and it is very clear so you can see through it.
Conclusion. As we can see from both of our results, it is clear that the more rapid you shake a solution, the faster the solute will dissolve in the solvent. This is because in a mixture like salt water, the shaking breaks the salt crystals, allowing more water to attach to the salt molecules, dissolving them more quickly. As seen by our second test, we shook more slowly, creating less force to break the salt crystals apart, leaving more that did not dissolve completely.
Does our data support our hypothesis? Our data does support our hypothesis because we said that the faster we shook the mixture, the faster the particles would dissolve. Both of our experiments proved our hypothesis. If you refer back to pictures 1.6 and 1.7, it shows how one dissolves faster than the other due to shaking speed.